So this topic, I'm going to take lactase and beta galactosidase. So let's first take lactose intolerance. Lactose intolerance, or you will say lactase deficiency. Lactase deficiency. It can be primary or secondary. Primary is that the enzyme is deficient. Enzyme is deficient. Secondary is because of some other reasons, and that is loss of intestinal brush border. It may be due to gastroenteritis. It may be due to autoimmune disease. So that is secondary. That the reason is not enzyme deficient, but the reason is some other than the enzyme deficiency. So that is secondary enzyme deficiency. So in lactose intolerance, lactase enzyme is not there. This enzyme lactase breaks down lactose into two monosaccharides. You know, lactose is a disaccharide made up of two monosaccharides, galactose and glucose. In intestine, this enzyme is present in intestinal brush border and it can break down lactose. Lactose is present in milk and milk products, so that can be broken down to galactose and glucose, right? Clinical features of lactose intolerance are osmotic diarrhea. Patient has distended abdomen because of gas. Patient has flatulence, and this patient is also having vomiting, bloating, flatulence, right? What is the treatment? Treatment of lactose intolerance is we have to avoid dairy products, milk and milk products are avoided, but lactose-free milk is available. Lactose-free milk is available, which can be given to these patients, and also this enzyme lactase can be given to these patients. Lactase pills are available, which can be given for treating the patients of lactose intolerance, right? Now, this question is sometimes asked. They will give you a clinical picture of lactose intolerance and they will ask which enzyme is deficient. But in the option, lactase is not given. So now what is the other name of this enzyme, lactase? Let me tell you, this lactose is made up of galactose joined to glucose with beta bond, right? Mostly we have alpha bond in our most of the molecules. Alpha bond is there, and in human body it is very easy to break alpha bond, right? But beta bond is not broken. Beta bond is very difficult. It cannot be broken in body. So most of the time we don't have enzymes to break beta bonds in our body. For example, cellulose is made up of beta glucose, that is not broken down in our body. Inulin is made up of beta fructose, that is not broken down in our body. So beta bond is very difficult bond, not broken most of the time. But when it is lactose, then we have enzyme lactase in our body for breaking this beta bond. So what point I'm making here is that mostly beta bond is not broken, but if beta bond is present and on one side if galactose is present, then any such enzyme is known as beta galactosidase. So the enzyme here is lactase. Lactase can also be called beta galactosidase, right? Now there's one more disease, Krabbe's disease. They write in your medicine book, Harrison, that in Krabbe's disease also this enzyme is deficient. So you know, Krabbe's disease is something with myelin sheath and brain. In Krabbe's disease, what is the detail? Actually in Krabbe's disease, this compound accumulates. Beta galactosylceramide accumulates because the enzyme to break down this compound, obviously the enzyme is beta galactosylceramidase, right? This enzyme is not there in this patient, right? So what is this compound? This compound is galactose, a carbohydrate, joined with ceramide, a lipid, and these two compounds are joined by beta bond. This is a glycolipid, galactose joined to ceramide by beta bond, right? Now I told you beta cannot be broken. But if beta bond is there, and on one side, if galactose is present on one side of beta bond, then this beta bond can be broken, and any such enzyme is known as beta galactosidase. So, I summarize, this term beta galactosidase is a general term for any enzyme which can break beta bond on the side of galactose, right? In our body, we have two such enzymes. One is lactase, which is normally present, but it is absent in lactose intolerance. On the other side, one more enzyme is beta galactosyl ceramidase, which is normally present, but this enzyme is absent in Krabbe's disease, right? So this is the thing about beta galactosidase, that is a general term. So lactase also can be called beta galactosidase, and beta galactosyl ceramidase can also be called beta galactosidase. So be careful in the question which clinical picture they are giving you. Accordingly, you have to solve. Just be connected with your basic concepts, right? This is it. Best wishes to you.